Okay, everyone, I wanted to start going through Chapter 9 with you. I know that this is a little different than we would usually do, but I figured it would be good to go through this. I know some of you are struggling reading the textbook, and though as you get to college, you're going to need to learn how to read that textbook, how to learn from a textbook as well as in the classroom. I wanted to give you a video here to help support you learning the same material in the classroom. So I wanted to just make a short video to start things off. I'll be making videos like this every day, just going through materials. So let's start off with the main topic of the chapter. Chapter 9 is about testing a claim. Now, we test claims with things called significance tests. Okay, and there's a whole process behind the significance test. That's what a lot of Chapter 9 is all about. And so, whenever we want to test a claim, we're going to use a significance test. Now, a significance test starts off by making sure we understand really what it does. Significance test, it's a formal test of a claim. Now, somebody can make a claim about a lot of things. Your textbooks uses the claim that somebody has an 80% shooting average, I think in free throw shots. But people can make lots of different claims. You can claim things about a disease. Oh, the spread of the disease is such. You can make claims about this. Now, oftentimes, your claims are a hypothesis. If you remember back in science class, especially in 8th grade, a hypothesis is an educated guess. You're like, well, I know a little bit about the material. I'm going to make a good guess on what the data results in or what the results are. And so you're going to come up with a hypothesis. If you're going to test a claim, it should always start off with a hypothesis. So one guy, he's like, I'm a real good free throw shooter, so I think I have an 80% chance to make it from the free throw. Or another person could say, you know what, I think that this movie was the most popular movie in America, or something like that. Anytime you start off with a claim, you can test it. Now, some tests, like the most popular movie in America, that one has to be looked at maybe not so much through significance test and statistics. It may have to be looked through just a comparison, because a popular movie nowadays doesn't count in the same way that a popular movie did back in the 1930s and 40s. So, with each claim that you make, you would want to use a different test. Scientific claims, you would want to go through the scientific method to test it. Whenever we're making a statistical claim, our hypothesis has to be about the statistics. And so that's one thing that we're going to be focused on. Okay, so a significance test is a formal test of a claim. Now, those claims are hypotheses, and so we actually have two different hypotheses that we come to. First, it's called the null hypothesis, and the null hypothesis is a simple claim that says that something's true. For example, the percentage of shots free throw shots is, and I forgot what the number was, p equals 0.8. Okay, that would be something like a null hypothesis. Looks like it froze again on me. There we go. All right, I'm still learning how to use this thing. So a null hypothesis would be something like the percentage of free throw shots is 0.08. Or, let me add this, percentage of free throw shots that I can make. Or it could be of all the students in school, around or exactly, depending on how you want to frame your claim, your hypothesis here. You could say roughly 500 of them are 5 feet 5 inches. Now, of all 1,600 or 1,700 students in school, 500 of them are 5 feet 5 inches. And you can test that claim. You could even make it a little bit more general in saying that they're within 2 inches of 5.5. So they're between 5.3 and 5 feet 3 inches and 5 feet 7 inches, not 5.5 or 5.3 and 7. Okay, that would be a null hypothesis. You're giving a specific thing that you think might be true. Now, the alternative hypothesis says, what if that's not true? What would it be? So an alternative hypothesis oftentimes goes like this. And specifically, if we were talking about the basketball kid, the percentage of free throw shots is, for basketball shots, you're probably not going to be better than that. It'd probably be less than. P equals 0.8. Maybe it's 0.7, maybe it's 0.6. But odds are, you would say it's less than. But you could also say, you know what, this guy is the best free throw shooter in the world. Maybe his percentage is greater than P equals 8. Okay, so oftentimes we would write it like this. Because we're saying the free throw shot is less than that, we would say P is less than 0.8. Okay, that's all our alternative. Now, if he's a hot shooter, we could switch it around. If instead of less than, we say more than, we might say P is greater than 0.8. Okay, so the percentage of free throw shots is less than 0.8 or greater than 0.8. Or, well, maybe you think it's any answer, but it's just not that answer. Okay? And so if it's any answer, but not that answer, you could say is not P equals 0.8. So that would lead to us saying P is not 0.8. It could be bigger, it could be smaller, but you're saying, no, it's definitely not 0.8. This creates different ideas. We have these one-sided versus two-sided hypotheses, okay? If you have a one-sided hypothesis and one-sided, that would be P is less than, or P is greater than, or the average is less than. Okay, it's only one direction. Okay, so one-sided would be in one direction. Two-sided could be in either direction. And so often with two-sided, we use the word not. P is not. So this one would look like this. P is not 0.8. X bar is not 3.4. Okay? The average is not this. Anytime you want to make a claim that's one-sided versus two-sided, if you're going to make the claim that's one-sided, you would say P is less than or P is greater than. And this requires you predicting a little bit. Specifically with free throw shots, oftentimes you want to be less than, unless their percentage is really low. You might want to say greater than. Whenever you're talking about the context of the problem, that's whenever you decided if it's going to be a one-sided or a two-sided situation. Right now, with the virus and everything going on that, a lot of people talk about percentages being one-sided, like this. For example, right now, the death rate, if you look at what some people are saying, they're like, the death rate is this high. But then whenever you base it off the total number of people that have the coronavirus, even though they don't have symptoms and so they haven't been tested, you would end up saying that the actual probability or the death rate, the proportion of people who've died, is actually a lot lower than what it is. All right. Or you could talk about the transmission rate. I claim that the transmission rate is 2.3. So I'm going to make a one-sided claim. I'm going to say the transmission rate is less than 2.3. Okay? And I could write it like this. Transmission is less than 2.3. Where the null hypothesis is that it is 2.3. If I wanted the two-sided hypothesis, I would say the transmission is not equal to 2.3. Okay? So in looking at these claims, you've got two different hypotheses that you're going to make. One is your null hypothesis. That's the one that, okay, I think this claim is true, and this is the number. And then the alternative hypothesis says it's either less than, or it's greater than, or it's just not what that number is. Now, for each one, you would want to think a little bit differently about it. If you're thinking about less than or greater than, you're going to be doing some things. If you're thinking about just not being that value, you're going to do a few other things. So it's important to think about those different sides. With that said, I want to bring this kind of video to a close. We'll see if we can keep going from here.